Solution. So in this problem, we have to show that, or to test whether the given function satisfies properties for continuity. So solution, we check if one, limit of the function x approaches 0, y approaches 0, x cubed minus y cubed over x squared plus y squared exists. And then number 2, limit as x approaches 0, y approaches 0 of this function x cubed minus y cubed over x squared plus y squared is equals to f at 0, 0, which is already given in the function as 0. So if you are able to prove these conditions, then we'll conclude that the function is continuous at the point 0, 0. If at least one of the two conditions is not satisfied, then we say that the function is not continuous at the point 0, 0. So limit as x approaches 0, y approaches 0 of the function x cubed minus y cubed over x squared plus y squared along the x-axis, then this is the same as limit as x approaches 0. So along the x-axis, all the values of y are 0. So replacing where there's y by 0, I'll have x cubed over x squared. So this is the limit as x approaches 0 of x, which is 0, and I call this one value f1. Next, along the y-axis, all values of x are 0. So replacing for 0, where this x will have minus y cubed over y squared of y approaches 0. This limit as y approaches 0 of negative y. So which will be still 0. Call this one f2. Now, since f1 and f2 are the same, so here f1 equals to f2, then we go to step 3, limit x, y, x approaches 0, y approaches 0 of the function x cubed minus, then put y equals to mx. So approaching the origin through the line y equals to mx. Will be limit. So because now everything will be in terms of x, so then just write x approaches 0. So where there's y, you put this. So we'll have x cubed minus m cubed x cubed, x squared minus plus m squared x squared. By doing this, we can write this one as limit x approaches 0. So factor out x cubed in the numerator. So we have 1 minus m cubed divided by factor out x squared, 1 plus m squared. So this is the same as limit as x approaches 0. Now x squared, we'll cancel this one to get x into 1 minus m cubed divided by m squared plus 1. And by direct substitution, we'll get this to be 0 over m squared plus 1, which is 0. call this one f3. So remember, you can specify this is along x-axis. This one is along y-axis. So this second step. And then the third step is along line y equals to mx. And then since f1, f2, f3 have the same value, since f1 equals to f2 equals to f3 equals to 0, then we test for y equals to m x squared. And if it turns out that the value of the limit will be the same as f1, f2, f3, then we conclude that the limit of the function is 0. But let's see. So we'll have limit as x approaches 0, y approaches 0, of x cubed minus y cubed divided by x squared plus y squared will be given by limit. Now everything will be in terms of x, so just be x approaches 0, x cubed minus, this will be m cubed. And then when you say m x squared power 3, so 3 times 2 is 6, so x power 6 divided by x squared plus m squared x power 4. And then this is the same as limit x approaches 0 of, common here is x power 3 into brackets 1 minus m cubed x power 3 over x squared into 1 plus m squared x power 2. Now, by cancellation, we'll have limit as x approaches 0. Now we'll have x into 1 minus m cubed x cubed divided by 1 plus m squared x squared. Direct substitution will give the numerator for this function to be 0 because I'm multiplying x by this bracket. So I'll get 0. Denominator, this part will be 0, but I'll have 1. So 0 over 1 is 1. 0 over 1 is 0. So it turns out that this other value is the same as the previous values. So call this one f4. Now you say since f1 equals to f2 equals to f3 equals to f4 equals to 0, then the limit of the function, the limit of f of x, y exists and is 0. That's to mean, i.e., limit x approaches 0, y approaches 0 of the function x cubed minus y cubed divided by x squared plus y squared is 0. Now, since already in the function itself, we were told that the value of the function is 0 when x is 0 and y is 0, then it means that the function is already defined at the point 0, 0. So next statement you say, since f at 0, 0 equals to 0, that's i.e. is defined, or you can say exists, and the value of the limit x cubed minus y cubed over x squared plus y squared. As x approaches 0, y approaches 0 is 0, which is the same as f at 0, 0. The function f of xy given is continuous at the point 0, 0. So that is how we are supposed to do that particular problem. Thank you.